Hello friends, in this session we are going to see what kind of matrix operations we can perform. So here we are going to talk about equality of matrices, equality of matrices. Then we will be discussing the arithmetic operations on matrices, arithmetic operations. Then we will be learning dot product, and then we will be learning the inverse of a matrix, inverse of a matrix. Now, these operations we are going to discuss about. One more thing here going to discuss before inverse of a matrix. Before inverse of a matrix, we are going to discuss the transpose of a matrix as well. After that, inverse of a matrix. So let's start, guys. So first of all, equality of matrices. So if we say equality of
Hey,
matrices.
wait! Are you enjoying the video? Well, you're definitely going to enjoy an absolutely free, personalized career counseling call with our counselors. Call on the number below and book your slot today.
If we have equality of matrices means if we have two matrices, let's say I have A and it has some shape M into N, and I have some matrix B, it is also having the same shape, and where Aij is equal to Bij. If whatever element we have at Aij, if it is equal to Bij, then we can say both the matrices are equal. Now the question is, what do we mean by the Aij? Now first of all, let's understand the generic representation of a matrix. Now let's say if I have a matrix A and it is suppose a 3 by 3 matrix, so we can say like this is the first row, A is the element, and it is available at the first row and the first column. It is available at the first row, second column, and first row, third column. The same way, second row, first column, second row, second column, second row, third column. Now we have third row, first column, third row, second column, and third row, third column. This is the generic representation. So this one we call them as Ij. Now this is Aij. Now the same if I have some matrix Bij, let's say Bij, if I say, so it will be like this: B11, B12, B13, B21, B22, B23, and B31, B32, and B33. So this is the generic representation. Now what the equality says, if we have two matrices of the same shape, let's say 2 by 3, if one matrix is 2 by 3, the other is also 2 by 3, and then each corresponding element in both the matrices are the same, then we can say it is a both the matrices are equal. Let's take one example. Let's say I have a matrix A and it is a 2 by 3 matrix. Let's say I have 2, 8, 8, and maybe 4, 1, 7. This is the one matrix. Now I have another matrix B. Now it is also having the same elements and it is of the same shape. Now here we can say A is equal to B, or you can say A and B are equal. A and B are equal. So this is what equality is. Now the next part is the arithmetic operations. If we discuss the arithmetic operations. Arithmetic operations on a matrix with a scalar, with a scalar value. This is first of all. Now scalar, as we know, scalar is any real number is a scalar value. Let's say I have a matrix. I have a matrix 2, 4, 6, 1, 5, 9. So if I want to multiply with any number, let's say I am saying 2. So 2 is nothing but a scalar value. It is a scalar value. And this is a matrix. This is a matrix. Now, in case of scalar, only multiplication or division is possible. We can multiply a matrix with a scalar value. We can divide a matrix with a scalar value, but we cannot add or subtract a scalar with a matrix. Now, in this case, what output we are going to get? Let's say this is the matrix A. Now, A multiplied by 2 will be this particular value will be multiplied by each element. So the resultant matrix will look 2 2 ja 4, 2 4 ja 8, 2 8 ja 16, 2 1 ja 2, 2 5 ja 10, 2 9 ja 18. So this will be the resultant matrix. Now the same way, if I say, for example, I have a matrix A, let's say 5, maybe 9, maybe 2, maybe 7, 4, 8, like this. And I say here the operation that I want to perform is A divided by 2. It means each element of A has to be divided by 2. So the thing is, generally we cannot divide like this. What we do, we say A multiply by 1 by 2. It means multiply each element of this particular matrix by 1 by 2. So we can say like this. So it will be what? 5 by 2 will be 2.5. It will be, let's say 4.5. It will be 1. It will be 3.5. It will be 2 and it will be 4. So this will be the resultant matrix. Now suppose if we have two matrices A and B, A and B. Let's say I have A and B and where A and B both are the matrices. So it means each corresponding element will be added. Each corresponding element will be added like this. Now how to do that? This is the, we call it as the matrix addition. Matrix addition. When we have two matrices, then we say in this both the matrices have to be of same shape. In this case, to make the addition of two matrices possible, both the matrices both the matrices has to be of same shape. Have to be of the same shape. Now, suppose I have a matrix A and it says like this 2 4 1 5. Then I have a matrix B and it says maybe 3 7 2 4. We have the values like this, and the operation that I want to perform is A plus B I want to do. So both the matrices I want to add. So in this case what will happen, each corresponding element will get added. So the first element that we have here 2, it will be added with 3. So 2 plus 3 will be 5. Then 4 will be added with 7. First corresponding elements 11. Now this 1 will be added with 2. So it will be 3. And this 5 will be added with 4 and we will be getting 9. This is the resultant matrix. We can say A plus B equal to. This is how we can add two matrices. The same way we can subtract two matrices. Now if we talk about the multiplication, we call it as the dot product or the matrix multiplication. The next part that we are going to discuss is the dot product or the matrix multiplication. Now, when we multiply two matrices together, so corresponding elements are not being multiplied. So the way we multiply two matrices together is a bit different. We call it as dot product. Now, how it is going to be done? Let's understand in detail. Now, two matrices can be multiplied only in the case, or we can say dot product is possible only in the case when I'm writing it, dot product is possible only when the number of columns the number of columns are the number of columns in the first matrix are equal to the number of rows in the second matrix. To the number of rows in the second matrix, then only dot product is possible. Let's take one example. Suppose I have a matrix A and I say 1, 2, 5, 3, 8, 4. So can we say this is a 2 by 3 matrix, 2 rows and 3 columns? And then I have a matrix B, for example, and it is maybe 7, 7, and or let's say here we have 2 and here we have 4, like this. And this is we have 2 rows and one column. So if we see whether dot product is possible, so you see the number of columns are 3 here and the number of rows are 2. So A dot B, this is how we represent the dot product, my friends, with the help of dot. A dot B is not possible here, is not possible. Why it is not possible? Because the number of columns in the first matrix are not equal to the number of rows in the second matrix. Now, if I have the matrices like this, suppose A matrix remain the same, 1, 2, 5, 3, 8, 4, and then the B matrix that I have, it looks like this, 2, 1, 5. So it is a 2 by 3 matrix and we have it here 3 by 1 matrix. Now if you say the number of rows here, number of columns in the first matrix are equal to the number of rows in the second matrix. Now here dot product is possible. Now the question is how it is going to be performed. Now dot product, we also call it as the row by column multiplication. Now how it is going to be done, let's understand. Let's say I want to do A dot B. It is going to be done like this. First of all, the first row we have to select here. So the first element of the first row 1, it will be multiplied with the first element of the first column. So we will say 1 multiplied by 2. We will be doing like this. So we will say 1 multiplied by 2 plus. Then the second element that we have, this one, and here the second element from the column. So second element from the row and second element from the column we have to take. So it will be 2 multiplied by 1 plus. Then what do we have to do? We have to take the third column, third element. We have to take the third element. This is now third element and here also the third element. So it will be 5 multiplied by 5. 5 multiplied by 5. So first row is complete. So now we have to move into the second row. In second row again what we are going to do? All the elements one by one we are going to do. 3 multiplied by 2. So first of all we will be doing 3 multiplied by 2. So it will be like this plus 8 multiplied by 1 plus 4 multiplied by 5. So in this case we can say A dot B equal to, and here 2 plus 2 plus 25. So 2 plus 2 4 and 25, it will be 29. And here if we say 3 2 just 6 plus 8 14 and 45. 45 plus 14 I think 59 it will be. So this is, and the resultant matrix is of 2 by 2 rows and 1 column. So the resultant matrix is always from the first matrix we have to take the rows and from the second matrix we have to take the columns. Of this shape we are going to get the resultant matrix like this. This is how we do the dot product. We can have one more example where we have more rows or columns. Let's try it out. Let's say I have a matrix and it is a same 3 by 2. Let's say 1 3 2 and then we say maybe 4 7 and let's say 1 like this. And then we have B, and we have here two rows, for example, 2 2 3, and we can say 1 5 2 like this. Now this is a 2 by 3 matrix, and this is a 3 by 2 matrix. Now if we see here, the number of columns in the first matrix are equal to the number of rows in the second matrix. So dot product is possible, and the resultant matrix will be of 2 by 2 shape. The resultant matrix will be of 2 by 2 shape. So this is how we can see here. Now let's do it. So what I'll be doing, 1 multiply first row first column. This is first row element by element, and I will take the first column here. So how to do that? 1 multiply by 2 plus 3 multiply by 2. So 1 multiply by 2, then 3 multiply by 2 plus 2 multiply by 3. 2 multiply by 3. Now first row first column is completed. Now what I'll be doing? I will take the first row and the second column. So I will take the first row and the second column. In the first row, second column, it is going to be 1 multiplied by 1 plus 3 multiplied by 5 plus 2 multiplied by 2. And this is what we have got. We have got the, sorry, my bad. It is the second column, right? So it has to be placed here like this. 1 multiplied by 1 plus 3 multiplied by 5 plus 2 multiplied by 2. Now we will be taking second row and the first column. So it will be 4 multiplied by 2 plus 7 multiplied by 2 plus 1 multiplied by 3. Now the second row and the second column we will be taking 4 multiplied by 1 plus 7 multiplied by 5 plus 1 multiplied by 2, and this will be our resultant matrix. So if you see the resultant matrix, this will become one element. So can we say it is a 2 by 2 matrix? So we have seen it will take the row from the first matrix and column from the second matrix. So if we calculate them, so let's say 2 plus 6 plus 6, 14, if I'm not wrong. Then here we have 8 plus 1, 9 plus 4, 13. Now if we say here 8 plus 14, it will be 22 plus 3, 25. And here it will be 4 and 35, it will be 39, and 2 41. So this is our resultant matrix. I hope we are having the sense of it, my friends. So this is how we do the dot product of two matrices Now next is the inverse of matrix we are going to discuss. Before inverse, let's discuss the transpose of a matrix. Transpose of a matrix. In transpose of a matrix, what we do, the now rows are getting converted into columns and vice versa. So what we do, the rows get converted into columns, and the columns, they get converted into rows. So if we do this, this is, we call it as the transpose of a matrix. Let's do it. Suppose I have a matrix A, and it looks like this: 1 2 3 4, maybe 7 9, like this. This is my matrix A transpose. It is, we represent like this. This is the transpose of A. So the first row will become the first column. So here we will be having the first row. First row will become 1 2 7. First row has become first column. Second row will become second column. It will be having 3 4 9. 3 4 9. So this is how we do the transpose. So it is a 2 by 3 matrix, and now we are getting a 3 by 2 matrix. So the number of rows and columns will get interchanged. This is, we call it as the transpose of a matrix. Now the next we can see is the inverse of a matrix. inverse of a matrix. Now, what is the need of inverse of a matrix? Suppose I have some equation and three equations I have. Let's say x plus 2y plus 3z and maybe 15. Then I am saying 2x minus y plus z equal to 5. Then I am saying 3x minus 4y plus 3z equal to 18. Anything. Let's say we have three equations. If we say three linear equations we have, and we have to solve it. So there might, we mathematically, as we used to do in our school days. So I can multiply some variable with some value. I will make them equal, and I will start eliminating the variables one by one. First of all, I will calculate the value of x, then I will put the value, then I'll be getting y, and then I'll be getting z, like that. The another method is we can use the matrix calculations, and if we do the matrix calculations, we can represent them like this. First of all, we can take the coefficient. So here it is 1, here it is 2, and here it is 3. Here it is 2, here it is minus 1, and here it is 1, 3. Here we have minus 4, and here we have 3. This is the matrix, and we can say this is A. Now we can take the variables, and the three variables we are using, and variable generally we represent by the X matrix, and we have three variables X, Y, and Z. These three variables we are using in this. Now we can say the resultant matrix, and let's say the resultant matrix is B, and here in the result we have three values after equal to 15, 5, and 18. So we can say 15, 5, and 18. So the same thing in matrix calculation we represent like this. A matrix we multiply by x, it is nothing but the dot product equal to B. This is how we represent. If I solve this equation, I will be getting the values of x, y, and z, my friends. Fine. Now how to do this? So I need the value of x. My job is to calculate the value of x. Now how do I calculate? So like if I say ax equal to b, so we can say x equal to b upon a. X equal to b upon a. Can we say this? Generally in math we do, in mathematics we do like this. And here if I do, let's say from here if I say a dot product x equal to b, so we can say x equal to b upon a, where a is a matrix, where a is a matrix. Now mathematically this is, we can see, okay, this it looks like we can do it, but with matrix it is not possible. We cannot divide any matrix with another matrix. Division with a matrix is not possible. So what we do, instead of writing this, we multiply, we can say here a equal to 1 upon a dot b. We can say like this, and this 1 upon a we represented with the name of a inverse b. A inverse b. So this is how we calculate. This is how we calculate. So if I solve this equation, I will be getting the value of x, and if I get the value of x, I will be getting the value of those, or in x we have all the three variables x, y, and z, and my equations will get solved. So this is the requirement to calculate inverse. Once we know the inverse of a matrix, we can solve multiple linear equations together. Fine. Now the how to calculate inverse of a matrix. Now that we are going to see in the coming session. Thanks.
Did you enjoy the video? I'm sure you did. And just like this, you're going to enjoy an absolutely free personalized career guidance call with our counselors for free. Call on the number below and book your slot today.